today, you should have your textbooks out, pages 156 to 158. Okay? Hope you guys have been taking advantage of listening to the videos. This is going to be a critical part of your preparation for your final exam next week. We're solving equations in Chapter 3, various methods and techniques involving that. Most simply in 3.1, 3.1 involved the idea of adding or subtracting numbers from both sides of an equation to arrive at a value for a variable. In problem number 4, y minus 13 is equal to 12. We've got to get y by itself. In order to do that, we're going to add 13 to both sides. One second, my computer's not wanting to work with me. Here we go. Need to add 13 to both sides. So when I do this, that assures that we don't change the overall value of the equation. Remember, if you add or subtract something to one side of the equation, you've got to do the same to the other. And that's going to give us y is equal to 12 plus 13 is 25. You should put these values back into the expression to see if it does work. 25, you can tell whether or not you got these right. You don't have to wait for me to check it. If you put 25 back in there, 25 minus 13 is equal to 12. You can see that it does work, right? So you should do this. It does check. Now what I want y'all to take a moment to do on your own is I want you to do number 6. M plus 1/2 is equal to 5 over 6. Okay? All right, I want y'all to listen up very carefully here. Some of y'all have got calculators that are letting you put fractions in and kicking out these simplified answers. You're going to have to show me how you got that. If all you do on the test, you decide n plus 1/2, you subtract 1/2, which is correct. That is what you need to do. But if your calculators are allowing you to just put in 5 over 6 minus 1/2, and yes, the answer is 1/3, but you can't show me how that's true, I'm not going to count that. Understand? I need to see the work. No, the calculator got it right. I need to see that you got it right.
But in the real world, we can use calculators.
This is your real world right now. This class is your real world, and I'm telling you, you've got to show me how to do it. Okay? So to do it is this: 5, 6. You're going to have to change 1/2 to something over 6. You've got to rewrite that fraction. The least common denominator between 2 and 6 is 6, right?
Yes, sir.
What do I have to multiply 2 by to get a 6?
3.
So what's 3 times 1?
3.
If you multiply the bottom by, you got to multiply the top by. So what you're looking at here is 5 minus 3 over 6. 5 minus 3 is 2, and you should be able to see that 2 over 6 is simplifies to 1/3. Okay? That's what m is equal to. So m is equal to 1/3. Okay, so I want to stress this. M here is equal to 1/3. I want to see the work. If you want to use your calculator to check yourself, that's fine, but you're going to have to show me how it is, algebraically, that this is true. All right? It's non-negotiable. Now, problem 3.2. On this particular problem, you've got a negative 4g. You erase this. Equals to a negative 56. This time, the variable is going to be multiplied by some coefficient. You have got to write the coefficient of the variable as a positive 1. In this particular case, if I want to find out what g is equal to, if a negative 4g is a negative 56, what's g equal to? I've got to divide both sides by a negative 4. And the negative 4 is canceled, leaving me with g. A negative 56 divided by a negative 4. I know that's going to be a positive expression, and yes, the answer is going to be a 14. Now what you should do is put that 14 into the problem as a negative 4 times 14 equal to a negative 56. And I think that you'll see that it is true. So the problem checks. All right. Now I want you to do number 18. This was problem, I think this was problem number 12. Okay. Number 18, negative c over 3 is equal to 12. Play with that one, all right? All right. But negative c over 3 is equal to 12. Most of you guys got this, okay? Multiply both sides by 3, right? But then that's going to give you, when you do that, 3 here, 3 here. That's going to give you a negative c is equal to 36. Now, you're not done yet. You want to know what a positive c is equal to. Divide by negative 1, multiply by negative 1, however it is you want to think about this. The negative's got to come over. Okay? Now, if you multiply both sides by negative 3, you could have taken care of the negative and that denominator of a 3 at the same time. But whatever it takes to get you to this answer. But you should put this back in. The negative c is equal to, if c is equal to a negative 36, then the negative, this is what it would look like to check it. If you decided to check it, the negative of a negative 36 equals to 12. Is that true? This becomes a positive 36 over 3, and that is a 3. All right? And yes, it does check out. So it checks. Now, down into the next section here. 3a plus 7 is equal to 31. And then problem 25, a negative 7 is equal to 4 plus x over 3. I want you to work on these two right now, okay? Now, both of these, you've got to be careful because there's more than one step involved. These are like two-step equations is what they're referred to as. So what you're going to have to do, first of all, subtract 7. And only subtract 7 from the left-hand side once. Some of you guys are subtracting 7 here. Then you're saying a negative 7 here. You don't do that, okay? You subtract 7 from the left-hand side of the equation once and once only. And that's going to leave you with 3a on the left, and that's all. Now, 31 minus 7, some of you are making some careless mistakes in your subtraction, that's going to be 24. Then you divide by 3, and a is equal to 8, and you should place that answer back into the problem to make sure that it works. Okay? In other words, it's 3 times 8 plus 7 equal to 31. I think it does. This is 24 plus 7. You'll see that it checks. Now, on number 25, you've got this. You got to remember the variable you want to get by itself. So it's not the negative 7 that moves here, but the 4. I want to get the fraction or the part of the expression with an x in it all by itself. So it's going to be 4 that I subtract. This particular problem, you guys are making several mistakes on this one. All right? A negative 7 minus 4, some of you were saying 3. You were saying negative 3. It's not. It's a bigger negative. It's a negative 11. Listen, consider your number line. Let's say the origin is here. Somewhere out to the left here is a negative 7. To subtract 4 means to move 4 more places to the left. 1, 2, 3, 4. What is that? Where does that place us? Where does that place us? A negative 11. So once we subtract here, this becomes a negative 11 x over 3 here. Now I think if you get that far, you'll be able to see what to do. Multiply both sides by 3. Okay? And when that happens, x will equal to, don't forget your negative here. Some of you guys were forgetting that. And you should plug that back into your answer. A little more work to see if it works, but you should do that. If you plug in a negative 33 here for x and negative 33 over 3, you should be able to see that's a negative 11, right? Negative 11 plus 4, it's going to take you back to a negative 7. It will work. And really on this, I would encourage you to do this. Wherever there's a problem that you can plug the answer back in and see what the answer is. See if it checks out. You don't have to wait to see if Mr. Schaub has told you if you've got a problem right or not. You can tell that on your own. All right, so here we go. 3.4. A little more complicated because now you've got variables on both sides of the equation. Same problem-solving processes. Each section in this chapter just stepped up, the complicated nature of the problems a little bit. So what I want to do on this one is understand I need to get the variables all on one side of the equation, right? So the first thing I want to do is subtract 2n. I'm just subtracting 2n, once from the right-hand side, once from the left. That's going to give me n minus 2n minus 6 equals to a negative 14, right? Now I want the constants all on one side, so I'm going to add 6. So now that's going to give me n minus 2n equals to 6 minus 14. What's n minus 2n? Be careful with your negatives here. What's n minus 2n? That's not going to be 3. A negative n. 1n minus 2n is a negative 1n. So I'm going to have a negative. I'm going to write that up here. Negative n. What's 6 minus 14? You should get a negative 8. Now, if a negative n is equal to a negative 8, what is n going to equal to? Multiply by negative 1 on both sides. N is going to be equal to 8. And you should plug that in there and make sure that it does work, and you'll see that it does. 8 minus 6 is what? If I plug this in here, what's 8 minus 6? No, 8 minus 6 is 2, isn't it? If I plug in a 2 for n here, 2 times 8 is what? 16? What's 16 minus 14? It checks. Now I want you to try this one. 5m, let me go scroll back up here. 5m minus 3 equals to 2m minus 9. Okay, so on problem 37, y'all did this pretty well. Most of you were getting this. Subtract 2m. That's going to give you 3m minus 3 equals to a negative 9. Be careful with your negatives. Add 3 to both sides. Now you're going to get 3m is equal to a negative 6. Okay, a negative 6. Then when you divide by, when you divide by 3, that's going to give you a negative 2. Okay, and you should plug that in there just to make sure that it works. Now we're going to go ahead and go into the next 2 problems here. Smart board can't keep up with me. All right, we're using our distributive property. This is the last, these actually 2 problems are in the last section of this chapter. Those ones we just did were 3-4. We're into 3-5. We're into the last section here with problem 48. This is as hard as it gets. Using your distributive property here, 7x, this minus 2 is going to distribute itself to both terms inside the parentheses. Both terms inside the parentheses are positive terms. Please do not forget to change the signs as well as multiplying by the 2. This is what you're looking at here. Not a positive 12, but a negative 12. Okay, equals to a negative 2. I'm going to add 12 to both sides. 7x minus 2x is 5x, right? So I've already got my like terms on the left-hand side with the, as far as the variables go. Adding 12 to both sides means I've got 12 minus 2, which is 10, isn't it? So 5x equals to 10. Divide by 5. And x is equal to 2. All right? Smartboard is just not letting me write some of these numbers exactly right. So you'll have to bear with me on some of this. All right? Now, let's go ahead and go to number 48. Number 48, I would encourage you to do this. You could multiply 6 times both terms inside the parentheses, just like we did before. And that's going to give you 12x. 6 times 7 is 42. Equals to 102. Subtract 42 from both sides, then divide by 12. If I subtract 42, I'm going to end up with 12x equals to 60, and then 60 divided by 12, x equals to 5. But and that's true. There's a little bit of a quicker way, if you can spot it, to work this out. And that's simply this. If I take the same problem I know this is 102. All right, I know 102 is divisible by 6. If I go ahead and divide both sides by 6, 6 goes into 102 a whole number of times. It's going to be 17. So once I do that, these 6's cancel. This becomes 2x plus 7 equals to 17. I think that's going to be easier to see to subtract 7, then divide by 2, then to subtract 42 and divide by 12. But whatever way that you want to go is up to you. Subtract 7, 2x equals to 10. And again, x is equal to 5, isn't it? It takes you to the same place. I just think this side is a little bit better. But whatever you feel more comfortable with, okay? All right, that's going to conclude our work today. Your homework tonight is going to be the Chapter 4 review, all the evens. And we'll work on it tomorrow.